Hi there. My name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students who are looking for a little more help as they study and prepare for the EQAO. It's video number 4, and in this video we're going to look at composite figures. So remember, a composite figure is a figure made up of two or more basic figures. And basic figures are the ones that you see on your formula sheet. So there are composite figures that exist in 2 dimensions, where we can study their perimeter and their area, or composite figures also exist in 3 dimensions, where we can look at the volume and surface area. So let's look at the first question. It says Jake builds an ice rink as shown below. Determine the perimeter of the rink. So clearly this is a composite figure. You can see that there is a rectangle, and added to that are 2 half circles on either end. So it's a composite figure. And we have to find the perimeter. So you do have the formula sheet, and the formula sheet can tell you, for example, that the perimeter of a rectangle is 2 times the length plus the width. And that's the formula because if you have a rectangle like this, for example, and you walked around the edge, you would do length plus width, and then length plus width, which is 2 times the length plus the width. Now that's great. The problem is that's a really useless formula to use in this composite shape. Because if I do the length, length plus width times 2, length plus width, then I'm for some reason including this piece and this piece in my perimeter. And clearly those are not part of the perimeter of this composite shape. So don't just look at the formula sheet blindly and not think about the information you have. When I find the perimeter of this object, I want to go like this. Pick a point to start and walk 25 something, 25 something. At no time do I walk over this 10-meter distance here and here. So again, the perimeter is 25 plus something plus 25 plus something. So what are those somethings? Well, those somethings are represented by the half circles. So I want to find the perimeter of a half circle. So obviously you know that perimeter is actually called circumference. And circumference is pi times diameter, and I want half a circle, so I'll divide by 2. So the diameter is 10. So I'm going to do pi times diameter, divide by 2, and that gives me 15.7 meters. So that was for this half circle, but clearly it's also for this half circle because that's also a half of a circle with diameter 10. So when I walk around this object, I will go 25 plus 15.7 plus 25 plus 15.7. So add that all together, and I will go 81.4 meters if I walk the perimeter of this ice rink. Okay, so now let's look at an area question involving composite figures. It says a soccer goalie is standing in a goal opening. From this position, she can guard the area represented by the semicircle below. How much of the goal opening is she not guarding? So the first thing is make sure you recognize this is a composite figure. There is clearly a rectangle here. And within that rectangle, we can see that the area she guards is this red semicircle. So this is what she can guard. And the question says, what can she not guard, or what is the area that she can't guard? So let's use green so it highlights this weird shape here plus this weird shape here is the area that I actually want. So how do we find that? Well, we know it's a composite figure. It's a rectangle and a semicircle. And instead of adding them together, which would look like this would be a composite figure where I add them together. What this question needs us to do is to actually subtract them, is to start with a rectangle and take away from it the semicircle, because what I'll be left with is just a shape that looks like this. So the pieces that are not represented by the semicircle. So this is what I want, and as you can see, it is a rectangle where someone took a piece out, and that piece is a semicircle. So this is a subtraction question. So first I need to find the area of the rectangle. And the rectangle length times width is 7.3 times 2.4. Oops, 2. Boy, this pen is not liking the number 2. And that gives me 7.4 times 2.4. Sorry, 7.3 times 2.4. That gives me 17.52 meters squared. So if the goalie was on the sidelines not guarding anything, then there would be a rectangle with an area of 17.52 square meters that was unguarded. However, she is not on the sidelines. She is standing where she's supposed to stand, and therefore she can guard a semicircle. So the area of a semicircle is pi r squared divided by 2, because that's exactly half a circle. So what's the radius of the circle she's guarding? Well, you can see here it's marked as 2.4. So pi times 2.4 meters squared divided by 2 gives me 9.04. Oops, sorry, got ahead of myself there. Divided by 2, let me try that again. Pi times the radius, 2.4 squared, ooh, squared, divided by 2. So calculate that in your calculator, and you get 9.04 meters squared. And that means that the unguarded area is the difference. This is the guarded area, so the unguarded area must be, subtract those, 8.48 square meters is unguarded. Okay, so here's another question. The picture measures 30 by 15 centimeters. The mat around the picture is 10 centimeters wide as shown. Find the area of the mat. So again, I want you to first of all recognize this as a composite figure. It's made up of 2 rectangles. A big rectangle in white, and then an internal smaller rectangle shaded in to represent the picture. So there's some sort of happy picture here, you know, scenery with a mountain and like a sun. I don't know, but this is the picture. So the picture is a rectangle, and it's kind of sitting on top of a second rectangle. So for me to find the area, the mat, which I'll color in with green to emphasize it, for me to find this green mat area, what I need to do is find the area of a whole green triangle. So find the area of this, and then subtract from it the part that is the picture, also a rectangle. So another subtraction question. So first, the area of the big rectangle is length times width. So what is the length? So from here to here, what is this measurement? Well, we know that this is 30 because that's the picture. This piece here must be 10 because that's the width of the mat. Well, this is also the mat, so that's 10. So 10 plus 30 plus 10 is 50. Same sort of idea on the width. We know that this distance is what we want. This much of it is represented by the picture. That's 15. This is the mat, and we know that the mat is 10 centimeters wide. So 10 plus 15 plus 10 is 35. So altogether, the bigger rectangle is 1,750 centimeters squared. That should be a 7, sort of looks like a 7. So then inside of that, we have a smaller rectangle, the picture itself, which we know is 30 times 15 centimeters, which is 450 square centimeters in area. And so therefore, the area of the mat is just the difference between them. 1750 is the big rectangle. The area taken up by the mat is 450. sorry, the area taken up by the picture is 450, and therefore the map must be the difference. That's 1,300 centimeters squared. So here's another composite question, but this time it's an addition question because the two shapes I have a semicircle like this, and below it, I have a trapezoid. Now, you can certainly take that trapezoid and think of it as a rectangle and two triangles. That's perfectly fine too. It just obviously it'll take you a bit more time. I'm going to pretend that I'm going to treat it as a trapezoid just because we don't often get to talk about trapezoids. So in this case, I have two shapes, and I'm going to clearly define them like this, because if I want the total area, you can see that all I have to do is find their areas and add them. So shape number one is a half a circle. So the area of a half a circle is pi r squared divided by 2. So all I need is the radius. So the information given to me, this 2, is centered on the line, which means its diameter. And so that means the radius must be 1. So I would do pi times 1 squared divided by 2. And that gives me 1.57 centimeters squared for the area of that semicircle. Now the bottom piece is a trapezoid. So if you look on your formula sheet, the area of a trapezoid is given as A plus B times H divided by 2. And I wanted to specifically use this formula, again, because we don't often talk about trapezoids. So first of all, you know that height, it must be perpendicular. And what must it be perpendicular to? Well, in this case, A and B. A and B in a trapezoid are the two sides that are parallel to each other. So A and B would be the 2 meter and 1 meter. Oh, it's meters. Just a second. There. So 2 meters is A and 1 meters is B. And then obviously the height must be perpendicular to them. So I'm going to take 0.75 as the height. So the formula would be A plus B, 2 plus 1, times 0.75 divided by 2. And what does that give me? That gives me 1.125. Certainly you can round. I'm going to save my rounding till the end. And therefore the total area would be the sum of these two things, 1.57. Ooh, 1.57 plus 1.125. So if I add those together in my calculator and then round to one decimal place, I get 2.7 square meters. Now, composite figures don't have to only exist in 2-space. This is a 3-space shape. And what you're supposed to do is find the height of this cone. But I just want to focus for a bit on this shape here. In fact, I've done this solution on another video, so it's out there for sure. If I wanted to find the volume of this, I would have to add together the volume of the cylinder. So there's clearly a cylinder. And then below that cylinder is this tiny little cone. So you would have to find the volume of the cylinder and add it to the volume of the cone. So that's a pretty straightforward thing to do. And again, you can see that in my other video. Or certainly, if you want me to show the whole thing here, just post it. But I also wanted to talk about surface area of these two items. Because what if you were to find the surface area of this shaded shape? Well, you'd have to be careful because where the two objects touch, that circle would not be part of surface area. So what you would have to do is you would have to use the surface area of a cylinder. You would have to use one circle, pi r squared, plus the lateral surface. So don't use 2 pi r squared because I don't want to include that circle. So I would do pi r squared plus the lateral surface. For the cone, same thing. I do not want to use the circle. So don't use the pi r squared part. Instead, use the 2rs part. Oops, I mean, not 2, the pi rs. Okay? So make sure that you don't just blindly use formula sheets on composite figures.